Okay, took a little break, now I'm back. Great. So we're on number 4, solve for m, where m divided by 9 plus 47 equals 74. Okay, let me get my little pen out again. And in this case, let me use this scenario again. If I knew what m was, I would do what first? I would divide it by 9, or I'll put the dot bar dot so you know what I'm talking about. The first thing I would do, following PEMDAS, if I knew what m was, is divide by 9. Then I would add that 47 to it, right? Okay, cool. Well, since I don't know what m is, I have to do everything in reverse order, and do the opposite operation. So the opposite of addition actually is subtraction. So the first thing I'm going to do to my problem is subtract 47. Oh, we don't divide the 9 first? Nope, not yet. Divide both sides by 47. Okay, so Miss Gibbs said follow the process and you'll be alright. There you go. Zeroed out, 0 pair there. So I'm left with m divided by 9 is equal to 74 minus 47 leaves us with, excuse me, what is that? 74 minus 47 equals 27. Sorry, I didn't want to do it in my head. 27, no worries. When you have a calculator, use it. Okay, and the other operation that I did prior to addition was division, so now I need to multiply. Oh, okay, multiply both sides by, who's bugging me? 9. Gotta get that m by himself, so multiply both sides of your equation by 9. Raise your hand real slyly, you're at home by yourself, it's okay. If you are about to say that m equals 3, I bet that's what you were about to say, but it's okay. Because now we cancel out our 9s and find that m equals 27 times 9 and not divided by 9. Told you about your eyes playing tricks on you, and you get 243. So m equals 243. And there you have it. It's probably another one of those text box things. That's all you need. Alright, let's continue. Number 5. We have negative 9 times the quantity x plus 3 is equal to, plus 5x equals 13. Y'all excuse me, I was trying to do 2 things at one time. That's what I get. Okay, one thing at a time. I see a lot of variables in here. I think I might need to take Miss Gibbs' advice and don't call her site. Don't call me after midnight. An acronym that we use in class to represent distribute when you see parentheses, distribute if necessary, combine like terms on each individual side separately, then move your variables to one side and your constants to the other side, and then undo addition or subtraction, then undo multiplication or division. Okay, let's go. Negative 9 times x gives me negative 9x. Trying to write with a mouse is not the most fun thing. Plus, I could say plus negative 9 times 3, which would give me a negative. I'm going to go ahead to save time. Plus a negative 27 plus 5x is equal to 13. Okay, copy everybody else down. Not fooling with them just yet. Okay, we've distributed. Check or scratch it off. Now we need to combine like terms. Okay, don't pay attention to the equal sign or anything on the other side. Let's just look to the left. To the left, to the left. Look for your like terms to the left. Negative 9x looks a lot like positive 5x. Remember, take the sign that is in front of each term, and that tells you what the sign is of the term. So we have negative 9 plus 5, same signs, add and keep. I have different signs, so I will subtract. The difference between 9 and 5 is 4x. Take the sign of the higher number, which is the 9, the absolute value that is. So that means my term is 4x. I have more negatives than positives. And now I'm going to subtract 27. That's the way I would have written it. Subtract 27. So this is gone and this is gone. I'm left with negative 4x minus 27 equals 13. Okay, don't mind if I go over here in this extra space. Now, I'm just going to copy negative 4x minus 27 equals 13. And now I have a plain old, regular, old school two-step equation. I can handle that. Undo your addition. Undo subtraction. Slow down, Miss Gibbs. Going too fast. Uh-oh. Sorry about that. Now that I do need to erase. There we go. Okay. Pardon me. And add 27 to the other side. Whatever I do to one side, gotta do to the other side. Fair is fair. Okay. So now positive and a negative 27 cancel out, make 0. I'm left with negative 4x on the left is equal to 13 plus 27, that's 30, 40. We've got 40 on the right. Okay, great. Now, negative 4x is my negative 4, is a coefficient. So divide by the entire coefficient so that it equals a positive 1. Divide by 4 on the right side. There we go. Negative 4 divided by negative 4 equals 1. I'm left with x is equal to positive divided by a negative gives me a negative. Do it and write it first. Now your numbers 40 divided by 4 equals 10. Put them together, you've got negative 10. X, my friends, equals negative 10. Easy enough. We switch colors to go to another problem. Oh, those are cute pens, but we're not doing that right now. Text pen. Don't know what that is. Okay, let's go with some blue here. Okay, solving for k. Negative 5k plus 11k equals 8k minus 12. That's a lot of k's. All right, so we are going to have to go back up here to don't call me after midnight. And do I need to do any distribution? No. Do I have like terms on the same side? Why, yes, I do. Negative 5k plus 11k can be combined. You could look at this as 11k minus 5k. I would. And then I'd just say, oh, I know 11 minus 5 is 6. Coefficients. Add and subtract the coefficients. So I get 6x. Or, if you didn't see it right away, then sing the stupid song. Miss Gibbs always says. Same signs? Nope, I have different signs. So I subtract the numbers and take the sign of the higher number. Then you'll be exact. So again, 11 minus 5 would leave me 6. Take the sign of the larger absolute value, which is the 11. That makes it positive. I'm sorry, I wrote an X, I meant K. It's okay. Keep it moving, Miss Gibbs. 8K minus 12. Awesome. Well, I guess you're going to have to be consistent. And you wrote an X, then a K, Miss Gibbs. You're not setting a very good example here. Let me fix it. I like X. I don't like the way I drew that K. No worries. I can write whatever I want on my paper as long as I get the right answer for the variable. Yep, I'm making up new rules. Now, we didn't have to distribute. We combined our like terms on each side because the right side we have unlike terms, so we're good there. Now move. Move the little guy. Okay, to keep everything positive, you can move the little guy, which is 6x, to the other side, subtracting 6x from both sides. And this is going to require an extra step, but that's okay. Who's counting? So 6x minus 6x makes a 0 pair. So I'm left with, moving over here, I'm left with 0 on the left is equal to, we have 8x minus 6x, which leaves us 2 x's minus 12. So I simply need to put the constant on the left hand side this time. So we'll add 12 to both sides. Easy breezy. So he disappears from the right and he appears in positive form on the left. So we end up with 12x is equal to 2x. And like we said, 0 pair there. I like to write a little 0 at the top, just to be sure. Okay, divide both sides by 2. You know the drill. X is now equal to 6. Easy breezy, of course. Lemon squeezy. I'll pause, let you write that down. Now, getting ready to erase and scroll up. So if you need a copy, go ahead and pause. Okay. So let me get my big eraser and poof, it's gone. There we go. Alrighty, now let us scroll. We are on number 7. Alright, number 7. Okay, what value of x makes the equation true? What value of x makes the equation true? Getting the pen? Okay, we have 3/4 x. Let me just rewrite it. 3/4 times x plus 7 equals 34. Okie dokie. If I knew what x was, I'd multiply first. Then add. Since I don't know what it is, I'm going to undo the addition by subtracting first. Subtract 7. Subtract 7. And I end up bringing down my 3/4 x. So it didn't do anything with him. And my 7s, oh, that's kind of weird. They cancel out. And therefore I'm left with 3/4 equals 3/4 x equals 34 minus 7, which leaves me 27. Okay. Now, just want to make sure I check my math, because I don't want to make any mistakes on here. 34, just making sure. Since I have a calculator, I'm using it because I'm a little sleepy. Anyway, now I have to undo multiplication with division. I could show you the long way, but in the interest of time, I can do it in class. Dividing 3/4 by 3/4 is the same thing as multiplying it by its reciprocal. So we're going to multiply both sides by the flip. Reciprocal, whatever floats your boat and helps you to remember to get it right, I'm cool with. Okay, on the left, 4's cancel out, equal 1. 3's cancel out, they divide. 3 divided by 3 is 1. Left with x on the left, or 1x, is equal to 27 over 1. Let me make that a fraction so you can see what I'm doing. I'm cross-canceling here. 3 and 27 are both divisible by 3. 3 divided by 3 is 1. 27 divided by 3 leaves me 9. So now I'm only going to have to multiply 9 times 4 to get 36. And then 1 times 1 in the denominator obviously means that's 36 over 1. So now I've already reduced it and I'm done. X equals 36. That answer is D. Okay? Going down. In which equation does the value of x not equal 2? Let's take a pause here and we'll start back in just a moment. Thank you.